A function f is continuous on the closed interval. We just looked at the idea of an open interval. On the closed interval AB, if it is continuous first on the open interval, and I need to add two more things to this. First, I'm going to draw a quick picture here. And let's just say I'm going from A to B, and the function looks like this. See, this would be, this would be continuous on the open interval. At these endpoints, it doesn't have to be continuous. What I'm talking about here now is the closed interval. So I want to change this to a closed interval. I want to see what needs to happen. Well, what needs to happen is this circle needs to be filled in. So how can I explain that analytically? Well, this is the same as saying, one, it's open on the interval, open interval A to B, and then two, the limit as x approaches A from the right, and A is just my left bound. It could be C or D or whatever you want to call it, of f of x is equal to f of A, and obviously that has to be a real number. This should go without saying. And 3, I need the limit as x approaches B from the left of f of x to be equal to f of b, which again is a real number. So what this is saying is that as I approach b from the left, my function doesn't have any jumps. It goes right to f of b. The limit goes right to f of b. So I'm not jumping up here. If f of b is piecewise is defined up here, the limit would not be equal to f of b. So that would give me a discontinuity, which obviously in that case this would have to be an open circle. But if the limit does equal f of b, then this doesn't exist as such. I can just get rid of that. Let me erase away here. That's good enough. And this is actually solid. And the exact same thing, we're saying the exact same thing for f of a. As we approach a from the right, the function is equal to f of a, which means there's no jumps, no skips in there. So let's take a look at a quick example here. I want to consider the continuity of f of x equals the square root of 9 minus x squared. Well, the first thing I want to do here is try to figure out where this thing's defined, because I know that for f of x to be defined, this has to be, this piece right here has to be either positive or 0. That would then imply that x, well, let's just say it like this. Note, I'm going to say f of x does not exist for absolute value of x greater than 3. So if absolute value of x is greater than 3, this is going to be bigger than 9. 9 minus something bigger will be a negative number, and the whole thing becomes undefined. And if I were to graph this, come out to negative 3 and 3. See, when x is negative 3, I get 0. When x is 3, I get 0. When x is 0, I get square root of 9, which is 3. And this actually looks like this. So what I want to do is this by itself is a polynomial. That's continuous everywhere. Because that square root, we've restricted our domain, which what we've done here. So I know, in other words, that this is continuous on the open interval. So I want to take a look now at the limit as x approaches negative 3 from the right of f of x, and that limit is in fact 0, which is equal to f of negative 3, so I'm good there. Now to look at the other side, I want the limit as x approaches 3 from the left of f of x. That's also equal to 0, which is also equal to f of 3. Therefore, f of x is continuous on the closed interval -3 to 3.